In Chapter 4, we are going to be working on constructing graphs of our trig functions. Today we're going to go over some basic sine and cosine curves, and we're going to find the value of sine and cosine from a graph. So in example 1, we're going to graph y equals sine of x. Then we're going to find all values of x between 0 and 2 pi for which sine of x equals the square root of 2 over 2. So to start off with, we're going to fill in this table, and we're going to go from 0 to 2 pi, and they give us all of our x values. We're just going to solve for what y equals. And we're going to start with y equals the sine of 0. And a lot of these values we're going to get off of our unit circle. And remember, our unit circle goes from 0, pi over 2, to just pi here, 3 pi over 2, and then back to 2 pi. And each of these has a coordinate point that we use to find our sine and cosine. And make sure you're labeling these carefully so you're not mixing up the ones and the zeros. And remember, each coordinate point gives us our cosine value and then our sine value. Our first one, we're finding the sine of 0, which would be 0, making our coordinate point 0, 0 for our first one. So to start off with, I'm going to do these 5 values on my table because I'll be able to find those right away. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. So I'm just going to fill those in first because I know exactly what they're going to be. So the sine of pi over 2 is going to be 1. The sine of pi is going to be 0. Which gives us the coordinate point pi 0. The sine of 3 pi over 2 is negative 1. And then the last one, the sine of 2 pi equals 0 again. So right away we have those 5 coordinate points. Next, it also wanted us to do the sine of pi over 4, which is part of our special right triangle, because pi over 4 is the same as 45 degrees. So we have our 45, 45, 90 triangle. So when we have the sine of pi over 4, that's going to be equal to the square root of 2 over 2. And you'll notice the next one that we have to fill in is 3 pi over 4. And we're going to do the same thing using our 45, 45 triangle because our reference angle is pi over 4 still. So if we have y equals the sine of 3 pi over 4, that's going to be positive square root of 2 over 2 again. And then if we go down to 5 pi over 4, again, we're going to use that special right triangle with the reference angle of 45 degrees. And this one is going to end up being negative square root of 2 over 2. And then our last one, we're going to have y equals the sine of 7 pi over 4. And this one, again, is going to be negative square root of 2 over 2. For these problems, you're not always going to have to fill out a table to draw your graph, because you'll notice the first 5 coordinate points that we filled in, we didn't even have to fill those out. We just got those from our unit circle. So eventually, we're going to be able to draw these graphs without even filling in a table. So that was step 1. We filled in these values. And I just wanted you to see the pattern, that we started at 0, we worked our way up to positive 1, and then we went back down to 0. Then we went down to negative 1 and then back up to 0 for our y values. So we followed our unit circle, and then we would just end up repeating this if we were to continue on. So now we're going to draw our graph. And on your graph, you are going to have to label your x and your y axis with the values. So on our x-axis, we went from 0 to 2 pi. So what I recommend doing is start with 2 pi towards the end, and then start cutting your x-axis in half. So we would have pi, and then cut those sections in half again, where we would get pi over 2 and 3 pi over 2. This way, your sections are going to be pretty even because it's easier to cut them in half than it is to create the same size sections by putting dashes. And then we also have our pi over 4s, and those ones I'm just going to put the dash marks, but I'm not going to put the labels because it'll get pretty crowded. And on our x or on our y-axis, we're just going to go to 1 and -1 because those are the highest and lowest values we have. And I'm going to start by graphing those 5 highlighted coordinate points on our graph because those ones have whole numbers. Our first one is at 0, 0, pi over 2, 1. Oh, nope, that was the wrong one. Pi 0. 3 pi over 2, -1, and 2 pi 0. And that is going to be our graph. So you'll notice that this graph is a curve, kind of like a wave. And then we were supposed to figure out which x values x equals the square root of 2 over 2. And we can get that right from our table. So square root of 2 over 2, square root of 2 over 2. And those are the only two spots that it's going to work at pi over 4 and 3 pi over 4 because you'll notice the other square roots of 2 are negative. So that's not the same value. So that's everything we need for example 1. Now we're going to move on to example 2. And we're going to graph y equals sine of x from -2 pi to 4 pi. And when we do this, the first thing I would like you to do is to draw your axes, and then we're going to label them. So this one we're going all the way up to 4 pi, cut that in half, cut that in half again, and cut those in half. Okay, so we've labeled our x-axis, and then our y-axis, again, we're going to go from -1 to +1. And when we graph this, we're going to use those 4 points on our unit circle to help us. So we have the coordinate point 1, 0, 0, 1, -1, 0, and 0, -1. And we are doing our sine function again, so we're looking at those y values. And we're going to be following from 0, pi over 2. I don't know why I keep putting a 2 there. That's supposed to be pi. And then 3 pi over 2, and back up to 2 pi. So let's start with those values, because that's going to help us get our graph started. So if we go to 0, the sine of 0 is 0. And then up to pi over 2, the sine of that is 1. The sine of pi is 0. The sine of 3 pi over 2 is -1. Sine of 2 pi is back to 0. So there we have one part of our graph completing our unit circle once. And you'll notice we'll just continue around that circle. So now we're back up at 2 pi. If we were to continue circling our unit circle, we would go up to 1 again, down to 0, down to -1, back up to 0. So we just keep working our way around that unit circle to continue our graph. Then if we were to work backwards and start at 0 to go to negative pi over 2, the sign of that value would be negative 1. And then 0, positive 1, and 0 again. And this is if we were to go backwards on our unit circle to get those negative values. And that would be our sine function. Noticing we did not even have to use our table of functions for this. All we used were those 4 points on our unit circle, and we got everything we needed to construct our graph. So that is the fast way to do these graphs without a table. If you would like to construct a table, you can still do that. This way usually just saves us a little bit of time. And eventually you'll be able to just draw a sine and cosine graph without even needing to reference this unit circle. Okay, there's a few vocabulary words that we're going to be talking about. The first one is a period. And a period for sine and cosine is one complete cycle. And you'll notice I colored these sections in different colors. So our period for our sine function, and this is where we have one full cycle of going from our maximum to our minimum and back to 0, that would be one period. And then in the green, I drew a second period. So this would be the length of one period as well. And notice between 2 pi and 4 pi, it's still the length of 2 pi for our period. And then our amplitude, you find your amplitude by taking your maximum minus your minimum and then dividing it by 2. So our amplitude is also just the distance from the middle of our graph to a maximum or to a minimum. So our amplitude for this one is equal to 1. And hopefully you've talked about domain and range before, where domain is all of the x values. So for a sine function like this one, our domain is going to be all real values, or all real numbers. And then the range is going to be our y values. And if you look at this one, y only goes from 1 to negative 1. So our range is described below in this set. Now we're going to move on to our next example. For this one, we're going to graph y equals cosine of x between negative 3 pi to 3 pi. So let's start by drawing our axes. So we're going to go to 3 pi. So this time, if we were to cut 3 pi in half, that would become 3 pi over 2. And if we were to cut that in half again, this would become 3 pi over 4. I think I'm going to do this differently. Sorry. Let's figure this out. So if we have 3 pi, if we cut this into thirds, that'll work better. So then we'll have pi and 2 pi. And then we could get pi over 2, 3 pi over 2, and then 5 pi over 2. Right? 2, 3, so that would be 1 more than 5. Perfect. And we need to do the same thing on the other side because we need to go to negative 3 pi. So if we cut that in thirds, we would have negative pi, negative 2 pi, cut those in half, negative pi over 2, negative 3 pi over 2, and negative 5 pi over 2. Now we can start by filling in our graph. And again, we are just going to be using those values from our unit circle, where we have 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And if you forget, remember it goes from 0, pi over 2, pi, 3 pi over 2, and then 2 pi. This time though, we are working with our cosine, and cosine is all of the x values. So now we can start by working our way through our graph. So if we found the cosine of 0, that is going to be equal to 1. Then the cosine of pi over 2 is 0. Cosine of pi is negative 1. Cosine of 3 pi over 2 is 0. And the cosine of 2 pi is 1. So notice we went all the way around our unit circle, so that is going to be 1 full period. Now let's continue working our way around. And we're going to follow that same pattern, going to 0 and then negative 1. So that's the rest of our graph going all the way up to 3 pi. Now we can go the opposite direction. We're going to start at 0 and go in the negative. So negative pi over 2, the cosine of that is 0. Cosine of negative pi is negative 1. Cosine of negative 3 pi over 2 is 0. And the cosine of negative 2 pi is 1. So that is another full distance around our unit circle. And if we were to continue, we would just follow that pattern, working our way around that unit circle. And that is what our graph should look like, going from negative 3 pi to 3 pi when we graph y equals cosine of x. And our last example, we are going to use the graph in example 3 to find all values, the key word here is all values, of x for which cosine of x equals negative 1. So if we write down some values where cosine of x equals negative 1, we would have negative 3 pi, negative pi, pi, and 3 pi. So you'll notice each time we are going a full 2 pi every time we go in between each different value for where cosine equals negative 1. So we're going to start with the first positive value of pi, and we're going to say cosine of x equals negative 1 when x equals pi plus, and then we're going to take the change that we're doing, so 2 pi, and then we're going to multiply it by a constant, where k is a constant. So all of the possible values for where cosine of x is going to equal negative 1, we can plug in any number for k. It could be a positive whole number or a negative whole number. And if we were to plug that in for x, we would end up getting a value of negative 1 for our answer. So that's everything you would need to do the homework for today. Let me know if you have any questions, and I'll get back to you as soon as possible.